Hello everyone, my name is Dipali Verma and today we will be discussing the triangle topic of a mathematics. Okay, so let's start. So we will be starting with the history of a triangles. Okay, and history of triangles, first of all we will be discussing the mathematician who has first used this symbol. Okay, so Chinese mathematician Jia Xian has devised or used the triangle symbol for the first time in the place of a coefficient. Okay, so what is a coefficient? Coefficient is a numerical value which we have to use again and again. So with instead of writing it again and again, we used a particular symbol or we use a particular alphabet which has been indicating the particular mathematical value. Okay, so we will he has used the triangle symbol as a coefficient. Okay, so next we will be further moving with the what is actually triangle means. So triangle is a has came from the Latin word that is triangulus, which means three cornered. Okay, and it also by name we can see that it has mean triangles. Okay, three angles, that means three angles. Okay, so three angles, in three angles, that means ki a figure that consists of a three angles and three sides. Okay, that is three cornered and three pointed. Okay, and further we will be moving it with the it is a one of the basic shape. Okay, and if we see the 2D plane, so in 2D plane it has been drawn a basic simplest figure. Okay, it is a simplest figure. Okay, that is simple polygon with the three sides and three angles. And one more thing we have to account for this, and that is the sum of the internal angles of the triangle. That means ki this is our triangle. Okay, now this is our internal angles, and sum of these internal angles, it will be our 180 degree. Okay, so sum of our internal angles of a triangle, it will be our 180 degree. Okay, so further moving on with the types of a triangle. So first type will be equilateral triangle. By name itself you can account that the equilateral triangle, that means ki everything should be equal. That is three sides of a triangle or three angles of a triangle, both are equal. And it means that three angles, that is three angles that will consisted in a triangle, will be equal to each other, and three sides of a triangle will be equal to each other in a measurement. Second will be isosceles triangle. In isosceles triangle, what happens, the two sides will be equal to each other but not equal to third side. Okay, and two angles will be equal to each other but not equal to the third angle. Okay, now third will be scalene triangle. In scalene triangle, no side will be equal to each other. All three sides will be different in dimensions. Okay, and all three angles will be differing in values of each other. Okay, so that is our scalene triangle. Next will be our acute triangle. Acute triangle means all the angles of a triangle, means all three angles of a triangles will be less than 90 degree. No angle will exceed the 90 degree. Okay, that will be our acute triangle. Now next is right angle triangle. In right angle triangle, right angle means ki we have got the idea that by the name itself, and that is our 90 degree. Okay, means one angle will be our 90 degree and other two angles will be less than 90 degree. Okay, and third is our obtuse triangle. Obtuse angle means more than 90 degree. Angle which is more than 90 degree. That means that we are sure by name itself that in a triangle one angle should be more than 90 degree, and rest of the two angles will be our less than, that is 90 degree. Okay, and I have drawn the figure in which we can see all the things. That is equilateral triangle, all three sides equal. Isosceles triangle, two sides are equal, third side will be different. Okay, in a scalene triangle, all the three sides will be different. In obtuse angle triangle, that is one angle will be more than 90 degree and other two will be less than 90 degree. Okay, in right angle triangle, one angle will be 90 degree and other two will be less than 90 degree. In acute triangle, all the three angles will be less than 90 degree. Is that clear? Okay, so let's move further. Now what are the applications of the triangle in a real life? Why we study triangle? Okay, so let's see some of the examples. There are umpteen number of examples, let me tell you. I mean umpteen number of applications of a triangle in our daily life, but some of the examples from that, it is, first we will be taking our Bermuda Triangle. I think everybody has been heard about the Bermuda Triangle. That is it is a very famous region that is on our Atlantic Ocean, and it connect basically our 3 point, that is Florida and second is Great Antilles, and third one is our Bermuda. Okay, so it is known as Bermuda Triangle, and it has been famous because of the more than 50 ships and 20 aircrafts. It has been vanished over there in that region, and that region resembles the particular our this shape, that is of triangle. That's why it is known as a Bermuda Triangle. Second is traffic signs. We have been often seeing on the road, that is our traffic signs. Okay, and that traffic signs basically are in triangle shape. Okay, and that is our equilateral triangle. Okay, means that is all three sides are equal and all three angles are equal of that traffic signs board. That's why it is an equilateral triangle that is used for the traffic signs. Okay, next is our pyramids. In pyramids we have been used the pyramid. Okay, pyramid is consist of a 4 equilateral triangles side by side, which forms a rectangle on the which forms a square on the base. That is, all sides are equal of the rectangle that is formed. That's why we will be calling it a square. So pyramid consists of 4 equilateral triangle. Next is our truss bridge. In truss bridge, our triangle has been considered as a strongest portion, strongest shape for distributing the load or weight. Okay, so that's why it has been used in a truss or bridges. So next is our sailing boat. Earlier in sailing boat we was using the rectangle or a square. In this curtain was of rectangle or a square shape, but nowadays we have been using it for the triangle shape. Why? Just because it can sail the boat against the wind. Okay, it is easy to sail a boat with a triangular shape curtain, that which will be helping in our against the traveling against the wind. Okay, next is our roof. In why we use roof in a triangle shape? Just to drain off the water, rainwater, and to drain off the snow. Okay, that do not stand there for the longer period of time. Next is our staircase and ladder, and that is, it involves the right angle triangle. Okay, now next is our building, monuments and tower. Basically, triangular shape gives strength to the building. That's why Eiffel Tower of Paris is consists of 186 triangles within itself, just to stay strong, and that is why it has been standing over there since a longer period of a time. Okay, let's move forward. Now next is in finding the height of a pole or a mountain, or I can tell you one more thing, that is our in finding the tower distance from ship. Okay, tower distance from ship, because these are the quantities we cannot manually measure it. Okay, we cannot manually measure the height of the tower from the ship, or height of the mountain, or height of the pole, just because we don't have any such device just to manually measure it. So we use the triangle properties to measure it. Okay, now next is sandwiches or pizza slices. Oftenly we have been using this sandwiches and pizza slices in a triangular shape, just because in a study survey it has been accounted that most of the children prefer the triangle shaped pizza or triangle shaped sandwiches just to have it. Okay, so let's further move it. Next is our similarity of a triangles. Okay, we will be starting with the next topic that is our similarity of a triangle. And that similarity of a triangle, that means ki, let us draw some figures. Okay, this is our triangle. Okay, this is our another triangle. Okay, now this is our circle, and this is our another circle. This is our rectangle. This is another rectangle. This is a square. This is another square. Okay, now just tell me, that is this figure similar to this? No, this is not similar to this, but this figure is similar to this figure. Okay, now next we will be seeing that this figure is similar to this figure. No, but this figure is not similar to this or this figure. Okay, similarly the rest of the two examples. Okay, so these figures are similar, but we can't say that are equal. Why? In this we can say that this side is equal to this side. Can we say that side A and this is side X? The side A is equal to X? No, side A is not equal to X. Okay, that is A will not be equal to X. Okay, that means कि they both are similar but not equal. It has been clear. That is, the similar figures are those figures which resembles similarity. Okay, that means कि this is triangle, so this is also triangle. That means कि they both are similar but not equal. That is, similar but not equal. Okay, so let's move forward. Next is our all congruent figures are similar but all similar figures need not to be congruent. What do you mean by congruent? We have already studied the congruent means I think that you have a basic idea of a congruent. That means कि congruence means equality. Congruent means equality. Okay, that is, if I draw a triangle like this, so let me do one thing. Okay, now these two triangles are congruent. Why? Just because these side, okay, this side is equal to this side, and this side is equal to this side, and this side is equal to this side, and this angle is equal to this angle, this angle is equal to this angle, and third, this angle is equal to this angle. Okay, so we can say that these two triangles are congruent. These and this are congruent. Okay, so let us take the value. That is 3, 3, 3, 3, 3, 3, and angles will be 60, 60, 60, that is 60, 60, 60. So we are seeing the same triangles, so they are congruent. Okay, if we take the two triangles, let us suppose that this is our triangle. Now this is our another triangle. Okay, so let us say it is 6, 4, 2, and this is 3, 2, 1. Now tell me that angles are equal. Okay, okay, angles are equal. That is, this angle is equal to this angle, this angle is equal to this angle. Let's name it A, B, C, X, Y, Z. Okay, so angle A is equal to angle X, angle B is equal to angle Y. Okay, and angle last is C. Okay, C is equal to angle Z. I have written again C. Okay, okay, angle C is equal to angle Z. Okay, these are equal angles, but are the sides are equal? This is 6, this is 3. Are this is equal? No, this is not equal, but they are in the same ratio as the small triangle. That means ki proportion, ratio or proportion is same. Okay, that means ki triangle, let's name this triangle 1, T1, and let's name this triangle 2, that is T2. That is, triangle 1 is similar to triangle 2 but not equal. Okay, so triangle 1 is similar to triangle 2 but not equal to triangle 2. Clear? So let's further move on. Okay, so that is, two triangles are similar. Okay, two triangles are similar. Now we have seen the conditions. Okay, which conditions has to be fulfilled for for triangles to be similar. Okay, so first is our their corresponding angles should be equal. Okay, we got that their corresponding angle should be equal, and second is their corresponding sides are in the same ratio or proportion. Here the angles are equal and sides are in proportion. That's why these two triangles are similar. In all the concurrent triangles, what we see that all sides are equal and all angles are equal. That means कि all three sides are equal and all three angles are equal and all three sides are equal. That means कि it is concurrent, but it is also similar. Okay, but in this we can see that it is similar but not congruent. That means कि we have understood the statement's meaning, that is all congruent figures are similar, but all similar figures need not to be congruent. Okay, next is we have got the two conditions, that is two triangles are similar if their corresponding angles are equal and their corresponding sides are in a same ratio or same proportion. They need not have to be equal, but their sides should be in the same proportion. Okay, so let's get one more example. Let's draw a two line. Okay, this is a two line, and in this we have got, let us divide this line into equal parts. Okay, let's name them P, Q, R, S, T. Okay, so this is our A, this is our Y, this is our X. Let's draw a line. Okay, let's draw a line from R on AY and name it as a B. Okay, now let's draw a line from T on a AY, let's name it C. So from the figure we can say that this proportion, that parts we have divided are equal to each other. Okay, such that AP is equal to PQ is equal to QR is equal to ST. Okay, now all these parts are equal, PQ, QR. Okay, we have forgot the RS. No issues. RS is equal to ST. Okay. Okay, so these five parts are equal. That is, we have divided this AX line into 1, 2, 3 parts, that is 3, and 1, 2, 2 parts, that is 2. Okay, so AR upon RT will be equal to 3 by 2. Okay, and again we have draw a parallel line, yani BC, that is BR is parallel to CT. Okay, these two are parallel lines, and we have drawn this line on the AY. So AY will be divided into same ratio, that is AB upon BC will be divided into equal ratios, in which AR and RT is divided, that is 3 by 2. Okay, now we can write that since AR upon RT is equal to AB upon BC, it has been proved. Okay, so I'm not saying that this line is equal to this line and this line is equal to this line in measurement, but what I am saying that this line part, this complete line has been divided into 3:2 part, yani proportion. What is the proportion of division? Proportion of division is 3:2. So in the same manner, this line is also divided into 3:2. That means ki this will be consisting of 3 parts and this will be consisting of 2 parts. That is, AC line is divided into 3:2 part, that is AB and BC. Okay, so this leads to our basic proportionality theorem. Okay, this leads to our basic proportionality theorem. Clear? So this will be all for the today's session. Thank you.